My drink fell and like splashed all over the place.
Oh,
that happened. Dealing with that. I'm glad that my accidents are your. I have to see how let's talk about what are you doing? Well, I don't want to know what he's doing because I want to know like how big that is, even though mine's kind of. I don't know. You're German. I know it's like coffee. Even though not everyone makes it.
I don't like coffee.
You guys are really good. You guys are really don't hate.
It's really good.
What is?
I actually did this whole sheet on my own. Proud of myself.
Very nice.
I was also up till 4 in the morning, but
Make sure you get that back to us.
Oh, wait. Wait. What's the entire
For me, I did. What do you want? Yeah, I thought he was cute. The only person at this school I'm getting that vibe. Remember Ryan from my brothers? Oh my god. Oh, I think it's like that. Not now. Yeah. He's like, one of those guys that I started playing with and I'm like, I'm like, okay, keep your vibe. Like, I'm a senior, you're a freshman. I'm like,
Shake.
I love these.
Monique, okay?
What?
Can I do it?
But I don't care.
No, the only thing is that was.
I hate classes. Damn. Okay. Oh yeah. I didn't know you were gonna leave.
Okay, let's get started. We have, I know in period 1, let me give you a second to situate yourself then.
Can I finish how you died?
There's more people coming.
Okay. Well, we got to get started.
No, I know. I'm sorry.
So, I think the big thing here is, in period 1 it was kind of confusing because we didn't see the numbers. So, I thought I'd recreate the chart here and just remind you that we're looking at residual is equal to the actual minus the predicted. So if this is a residual right here, this negative 0.08, negative 0.08 is equal to the 76.5 minus this unknown value here. That's what we have here. Negative 0.08 is equal to 76.5 minus the unknown value of x. Solve that any way you like, but you will get 76.58 here. So I'll just take that 76.58, stick it up here, perhaps highlight it. That way we know where things came from. Okay. Same thing's true here. The residual value unknown is equal to 76.8 minus 79.9. So 78.7 minus 79.9 is negative 0.034. I'll take that value, copy it, and we'll put it here. And that's where that comes from. The exact same thing gets done on line 3. The residual 0.4 is equal to the unknown minus 81.6. So the residual 0.4 is x minus 81.6. If you solve, you get an 82. So I'm just going to take that 82 and write it in there. 82. Okay, that's about 82 there. Next, we have this 0.69. This 0.69 is 84.8 minus the unknown. So where is that? 0.69 is 84.8 minus unknown x. Solve that any way you like, and you get an x equal to 8411. So I'll take that 8411, pop it up over here. Let's color code that with purple. And that's where that came from. The last entry is the age right here. And it's, you can see the pattern, 18, 21, 24, 27. And I just want to make sure that the next one is still going to follow that pattern 30. Most likely it will. So we're going to see the predicted value, 86.62, is equal to the linear regression at some point x. You're going to solve for that point x, and you're going to get 30.01, which is close enough to 30. I think you could put 30 there and you'll be fine, just because those two numbers are close enough. So that's good. And that's where all of that comes from. Okay, yeah?
I have a problem with this one. I never understand how to get the line in between. It doesn't work with line.
Line,
Like that line.
that's the LSRL.
Yeah.
Okay.
We tried figuring that out in first period, but it didn't work.
Okay, so for that one, to get that LSRL there, when you, now I gotta wait for the calculator to catch up. When you do the LSRL here, you have to put Y1 there. So we're talking about how do you get the LSRL to show up in your scatter plot. And the way to do that is to make sure you have Y1 in this row that says store regression. Oh, yours is different.
Yeah.
So for yours, you have to do L1, comma L2, comma Y1.
Where do I find Y then?
Vars. Y vars, wait. Function. And then Y1.
Sorry, can you repeat that? How do you
This is for the TI-83.
What about TI-84?
84 with the new operating system is just like this. Did it work?
I have to do the whole thing because I just.
Oh, okay.
That's figuring out.
All right.
Yeah.
Well, we can just go back and match part A even though.
Yeah. Okay. So I think that takes care of that part of question 4. Question 4C, I think it is a residual plot. This is 4B right here, isn't it? No, it's 4A. 4A. 4B, draw the residual plot. That's this right here. And my suggestion was, since there are only 5 data, it's easier to draw the residual plot without the calculator. Just go ahead and do that.
Do you have to label the residual side or just like one and negative?
Yeah, I would label it. Yeah.
Are we going to get a plot, or do we have to draw the graph?
It's possible you'll have to draw it.
No, I mean, like, are we going to be given a table, or no?
A table?
Like, we have to draw our own graph, like the lines.
Would you get your own coordinate axis? Yeah. Possible, not. You know, I've experimented with both, and it seems like students do worse when I provide them with a coordinate axis than if I don't. Yeah. I don't know why. Okay, so easier to go ahead and do that. Let's get these plots. So the x-coordinate, which was age, against the residuals. So the first is, 18. That first residual is negative 0.08. The next x-coordinate is 21. And that has a residual of negative 0.39. 24 has a residual of 0.4. 27 has a residual of 0.69. And 30 has a residual of negative 0.62. But as you can tell, that's not really a lot to plot. It's 5 points. So just go ahead and do it. 18 to 30. Notice I have mine, 18 to 30. You can scale that any way you like. But since you're counting by threes already, it makes sense to just count by threes. The biggest residual here is 0.69. So I have to get to at least 0.69. I went to 1. The smallest residual here is negative 0.62. So I went to negative 1. And then I just graph them approximately. As long as you're close, it'll be fine. Okay. Any questions on that? Okay.
Should my residuals change automatically when I put something into list 1 or list 2?
No. The residuals change when you do an LSRL.
No, like in the calculator.
Yeah.
Okay.
In the calculator, the residual change when you say lin reg L1, L2, Y1. When you use the lin reg function, that's when the residuals will change. Letter C, based on that residual plot, would you expect the growth pattern to be linear? Well, looking at that residual plot, I don't see a pattern. And you could kind of make up a pattern if you wanted to, but the data doesn't really support that pattern all that well. So at some point, you're just kind of making things up. So don't look too hard. You're smart enough to find a pattern. You know, you're smart enough to find a pattern in almost any set of numbers. So don't look too hard for that pattern. So the residual plot shows no clear pattern. This supports a linear relationship between age and height. Notice that the wording is not definitive, i.e., we did not say there is a linear relationship. And there's good reasoning for that. Okay. we have no idea if the linear relationship really exists. All we can really say is the data supports a linear relationship or the data doesn't support a linear relationship. We have no idea what the actual relationship is. And it's kind of one of those hard things to get across. The data either supports the model or it doesn't support the model. We have no idea what the data actually is doing. Okay? So it's important not to be too, I say the word definitive, but not to be too strong with your wording. Okay, that last part is to predict the height at 20 months is probably, hopefully the easiest part of this. You just substitute 20 into the LSRL. You get 78.24. And then you write down a statement here. When Joey was 20 months old, we predict his height would have been approximately 78 centimeters. As long as you word this correctly, you can round this number here. Questions on 4. Great. Okay, I think at this point we're going to go on to the multiple choice questions. Kind of previewed a few of them in period 3. We'll try and write them up now. Multiple choice. Okay, question 1. So a few thoughts about this. The first thought is that the scatter plot shows a negative relationship or a negative association. What that means is as one variable increases, the other variable decreases. How did I spell that wrong? Scatterplot's definitely a word.
Maybe it's not one word. See what it corrects it to.
I'm just going to add it to the dictionary.
It deserves to be in there.
Yeah, of course.
Thank you.
So this implies, or the implication here is R should be negative. The other idea looking at this is this scatterplot's pretty tightly banded. So that means we have a pretty high correlation. Tightly bounded. Is easy to visualize, maybe. Okay. So the implication here is R is close to -1. Okay. So that tells me that the correct choice here is A. Mm-hmm.
Can you also say that the reason it's R is closer to -1 because the slope is negative?
Yeah, that's the first part here.
Okay.
R is a negative number because there's negative association.
Got it.
Let's put that in there. Okay, problem 2. In that scatter plot, if the x values were decreased by 1 unit and the y values remain the same, the correlation, what would that do to the correlation coefficient r? Let's remember r is related to the relative position
R is related to the x value.
of each coordinate. Or quite literally, it's related to, r is related to, or computed, using z-scores. So let's think about that. If I just move all of them to the left or to the right, that's not going to change the z-scores. So it's not going to change the correlation, yeah. Yeah. Moving each coordinate to the, does it say left or the right? To the left by 1 unit will not change relative position or z-score. Therefore, r is not affected. You remember in, I'll get to you in 1 minute. Do you remember in geometry where they talk about rigid transformations? That was a long time ago. But rigid transformation just means the entire thingamajigger got slid over, or slid up, or rotated. Okay. If it's a rigid transformation like this, you're not going to affect the z-score. Yeah. Same thing. It's not going to change the z-scores in the y direction either. The only way to change that z-score would be to either spread the data out more or to squish them together more. Or add a... Yeah, add or remove data would do it as well. Okay. 3. Alright, so what does 3 say? In regression, the residuals are which of the following? This is either you know it or you don't know it. So the residual is the actual minus predicted value. For us?
Sorry to go back to number 2, but how would it change if the y was like it was moved up or down? Should it be the same thing?
Same thing, yeah. You're not changing the relative position. You're just sliding the whole thing up. Okay, so we're looking for any one of these that is actual y-coordinate minus predicted y-coordinate. And that one is B. B. So B is the best response there. What was the best response for number 2?
D.
D? That brings us to 4. Wait, are we done with 3? Let's look at 4. A local community college announces that the correlation between college entrance exam grades and scholastic achievement is negative 1.08. So, a couple problems with this one. Number 1, this says that the correlation R, or the question says R equals negative 1.08. Okay, so a couple of problems. Problem 1, this is negative association. Okay. This means as the entrance exam grade increases, the scholastic achievement decreases.
What is next to negative 1.08 I?
That's an I, yeah.
Why is there an
First point.
I? Oh.
First point. The negative association does not sound correct in context. Does it? Shouldn't. If the entrance exam grade is higher, then the scholastic achievement should also be higher, right? Not lower. This is counterintuitive, right? So most likely it's going to be a positive association here. If the entrance exam grade is higher, then the scholastic achievement should also be higher. But that's not even the worst part about this. The worst part about this is R needs to be between negative 1 and 0. No, negative 1 and 1. The given R does not follow the rule. Fine. Yeah. Okay. Does not follow the rule, so this is wrong. So the sassy correct answer is letter E. You can't report a correlation as negative 1.08. They're just making stuff up now. They must work for NASA or something. Letting Sandra Bullock float around in space like that. How dare they?
I like
How can you even think about
Yeah, they're really different.
completely
I
different.
think I like calculus better, but I don't know what it is.
I love calculus.
I don't like it. I like better.
I love
There was more math involved.
Yeah.
actually like
That's why I think I like it.
This is really
I think you know what it is calculus really it's a very mathematical thing,
Yes.
where statistics is more of a scientific thing.
Same. Why did we not?
Switch next semester.
It's different, but like,
Yeah.
I feel like the class had more,
But I like
like,
learning.
harder material, but there's this here there's more.
That's true too.
It's not was. Formula.
5. Researcher finds correlation between the traits greed and supercilious as negative 0.4. This is trying to catch you to make sure you understand that correlation in statistics is a property of quantitative what am I trying to say? Quantitative data. Okay. Supercilious. And what was the other one? Greed? Are not quantitative.
It's actually superciliousness.
Okay. So correlation doesn't exist unless you have quantitative variables. You could probably quantify superciliousness and greed, but the words themselves are not quantitative. Yeah, of course.
So, if you gave us like different categories that actually do have like many like this, but it was different words, would it all be trip? Even though, like, if you would say
The only way that
like if you did like use the height, if you just said like this, like height, the correlation between height and age was this, would it still be a trick question because you're not going to
no, not necessarily.
So because this doesn't have a quantitative data set,
Yeah.
that's why.
Because these are not quantitative variables. And I think we're good there. 6. 6, suppose the following information was collected. X is the diameter of the tree trunk, Y is the tree height in feet. We get an LSRL. What is your estimate for the average height of tree trunks with a diameter of 7? So let's make sure that we know this, because I know that mathematicians like to fool non-mathematicians by trading radius and diameter. So make sure we're talking about diameter.
Okay, well, what's the answer for 5?
It's a trick question.
Trick question, yeah. Okay, yeah, it says diameter and tree height. So we can just substitute a diameter of 7. So X is equal to tree diameter. And negative 3.6 plus 3.1 times 7. 18.1. So we would predict, or trees that are 7 feet tall, or 7 inches in diameter. Oh wow, spell it. Have a height I think a predicted height of 18.1 feet. Okay. Questions on that? I like how they give you the data and you didn't even need to use it.
Yeah.
That's helpful. Yeah.
We don't have to convert into speed or anything, right?
Not necessarily.
Like that.
7. The following are resistant. And I think the thing to know here is there's very little about in bivariate data, LSRL, that is resistant. I can't actually, off the top of my head, think of anything that's resistant here.
What does it mean by resistant?
Resistant means the effects of an outlier are minimized.
Okay.
So if you think about that, like we spent a lot of time talking about how an influential point, that's the opposite of being resistant. Okay. So if you can have if there is such thing as an influential point, it's not resistant. Okay. So none of these should be resistant. D. In fact, I can't think of any. I can't think of any resistant measures. Best response? D. Because definitely the correlation coefficient is definitely not resistant. The LSRL, not resistant. Eight. Data set has a correlation coefficient R equals 0.65, and another data set has a correlation coefficient R equals negative 0.65. Okay, so they have the same. They should have the same strength, provided that both are linear. So the points in A exhibit a stronger linear association than B. Probably not. The points in B exhibit a stronger linear association than A. No. Neither A nor B has a stronger linear association. Getting better. D. You can't tell which data set has a stronger linear association without seeing the data or seeing the scatterplots. That's the best one there. Okay. So correlation is an incomplete picture of the scatterplot, the association. Ship.
If it was R squared, would the answer be C?
No.
So what?
The thing is that remember that the data doesn't have to be linear, and you can still compute R and R squared.
Oh, and it would.
Yeah. Okay. Having a value of R does not guarantee that the data is linear in nature. Yeah.
If the R's were both like 0.35
Mm-hmm.
and then negative 0.35, would C be?
I still
Or
would.
you can't see because it's linear.
I'd still want to see the scatter plots and the residual plots. Okay. Making decisions just based on the correlation coefficient is a bad idea. Maybe I should write that down. Decisions based only on the value of the correlation coefficient are ill-advised. No. Okay, so that means that D is the best answer. Okay. It makes sense for 8. Don't make a decision just on R. ill-advised. You have to see scatter plots. You have to see residual plots. Nine. A set of data relates the amount of annual salary raised to the performance rating. An LSRL gives you y hat equals 1400 plus 2000x, where y is the estimated raise and x is a performance rating. Which of the following statements is not correct? Notice it didn't even say that the data is linear. So we're not even sure that the data is actually linear. For each increase of 1 point in performance rating, the raise will increase by an estimated or an average of 2,000. That sounds pretty good. Okay. The slope is 2,000, so for every one increase of 1 in the x-coordinate performance rating, the y-coordinate raise is increased by approximately 2,000. That's pretty good. B. This equation produces a predicted raises with an average error of 0. So if you average error, wait, so let's say A is pretty good, looks good. B. Average error. That sounds like the residuals. That sounds like the sum of the residuals divided by n. Does anyone remember what the sum of the residuals is? 0. It's property. Property of the LSRL, yeah. If you add the residuals together for any LSRL, you will get 0.
Can that be a question?
Yeah, that's possible.
You know, like, can you please put it on? So it's the only multiple choice that I'm gonna get right.
Oh, don't say that. C. A rating of 0 will yield a predicted raise of 1,400. Yes, this looks good too. Looks good too. The y-coordinate, or the y-intercept, is 1,400. So, it looks, oh, D, correlation is positive. This is good too, right? B is greater than 0. Therefore, R is greater than 0.
So if B is less than 0, R is less than 0.
That's true. E, best response. All of the above. Look, all of the above was actually one of the answers. Was actually the correct answer. None of these.
And you put on every single answer choice for every single test.
Yeah.
Yeah, I know.
You're proud of
The
them.
none of the above answer choice screwed me over so much in calculus.
Yeah, because sometimes it was actually.
It can be the correct answer. 1/5 of the time.
Actually, in your test, it was.
No, it wasn't. It was not more than 1/5.
No, there was a few tests that there was a lot. At least, like, you make us say what's the actual.
10. Okay, I'm looking at 10, and without even reading the question, it says the chart has P2 colon L1 comma resid. So that kind of strongly suggests to me that I'm looking at a residual plot.
It's a pattern.
This residual plot has a very clear pattern. Yeah.
What does the hat of the fan look like? You said there's 2 patterns that we look
Mhm.
like.
Let me do that after this question, okay? Okay, so study of fuel economy in various automobiles plotted fuel consumption versus speed, and LSRL was fit to the data. Here's a residual plot. What does the pattern tell you about the linear model? A, evidence is inconclusive. It's a pretty clear pattern. B, residual plot confirms linearity. Oh no. C, linear plot does not confirm linearity. Okay, that sounds pretty good, right? D, residual plot clearly contradicts linearity. So C or D? So does this clearly contradict, or does it simply not confirm? I feel like this changes every year. No, it doesn't confirm linearity.
But can you say that residual?
The answer is D.
Yeah.
Why is he wrong?
The residual plot is not the
I think that's the hard part with this one. C and D are both technically correct, aren't they?
One's just better.
One's better than the other.
I hate the one's better.
Yeah. Although C and D are both technically correct. D is the better choice, since the residual plot shows a very strong pattern. Curved pattern. Okay. If that curve was less pronounced, then you could probably have an argument for C. But when something is so clearly curved, you probably don't want to use it. Okay. $11. All but one of the following contains a blunder. Which statement is correct?
What's a blunder?
Mistake.
C?
Is that something we're gonna find on stat?
Yeah, it's possible.
I mean, like, or is that just, is that something that we'll find in the AP test?
I doubt they'll use the word blunder in the AP test.
We should know what other means.
Okay. All right, there is a correlation of 0.54 between football position player and their weight. What's the blunder? Yeah, which one isn't quantitative? Yeah. Position is not. Bye-bye. Football position is not quantitative. So, if we have a variable that's not quantitative, that means that regression doesn't make sense. How about B? What's our blunder in B? The correlation between planting rate and yield of corn is 0.23. I think that's pretty good, right? Sounds okay. C. The correlation between gas mileage and weight is 0.71 mpg.
You don't use an MPG?
Yeah. R, blunder. R does not have units. It is unitless. Unitless, like a Chinese manservant. Which dynasty was that? The last dynasty. No, not the Ming dynasty. Manchu dynasty.
Did you get the hat?
Hmm?
Did you get the hat yet?
No. $11. No, 11D. We found a high correlation between height and age of children. Yeah, R should be less than 1, right?
Yes.
So the blunder, -1, should be less. Ooh, what happened? Should be less than R, should be less than equal to 1. E. We found correlation of -0.63 between gender and political party preference. Gender and political party pref are not quantitative. Neither of those are quantitative. Yes. 12. Ooh, no. An LSRL predicts the height of a tree in the first 10 weeks outside the nursery to be blah blah blah, where y hat is the predicted height in inches and x is the number of weeks in the nursery, outside the nursery. Interpret the meaning of y-intercept and slope in terms of the data. Wow, we're really hitting that concept hard, aren't we?
Yeah.
A. Okay, so let's start with the slope, which is equal to 1.8 inches per week. No. Yeah. Okay.
Do I have
For
the slope equals b equals whatever, or can we just put slope is
you can just put slope is.
okay
I'm just putting that there for
us?
yeah. For every additional week outside the nursery, the predicted or the tree height increases by an average of 1.8 inches. Y-intercept, that's A, and that is 3.2. So a tree that has spent 0 weeks outside the nursery has a predicted height of 3.2 feet. Is it inches?
Well, you put inches.
Yeah, it's inches. Okay. B. Everyone okay with that, with the interpretations now? Please be okay with the interpretations.
Oh.
I've only asked you 5 or 6 times. a day.
Yeah.
B. Oh, my eyeballs. Estimate the height of a tree that has been out of the nursery for 6 weeks. Done. Predicted tree height is equal to 3.2 plus 1.8 times 6 weeks, 14. Please write it.
Oh, really? Oh, I thought you said it was okay though.
Hmm?
You said earlier it was okay if it's no problem.
I'm just thinking safe.
No, I think, yeah, writing the equation like an actual equation.
No, not the equation. I mean, like, y hat versus.
They already defined it.
Yeah, if they've already defined it, it's fine.
If that's what he was asking.
I just like, oh,
Not if we need to write the equation.
a tree that has been outside the nursery for 6 weeks has an average height of 14 inches. C. The actual height was found to be 12.5 inches. Calculate the residual. Residual is equal to actual minus predicted, which is equal to actual was how much? 12.5 minus predicted 14, negative 1.5. Yeah, here's one.
So for me, like, could you also write a tree that is an outside of the nursery for 6 weeks that has been predicted to have a height of 14 inches?
That works as well too. Yeah, John.
You said you didn't care how we can say x equals this, y equals this, and then write the equation. When-
Yeah,
Okay.
as long as you define x and y, no problem.
Okay.
13. Oh, this is the last one. An LS Lorel between train departure time after 5 o'clock and travel time found an R squared of 0.666. If the relationship has positive correlation, let's find the value of R. So R is equal to the square root of R squared, which is equal to the square root of 0.66 okay? I was surprised that it did square root for me.
If it said it has a negative correlation, would you just do the same thing but put a negative sign?
Yes, exactly. B. Explain the value of R squared in context.
What was R squared again?
It's 0.66.
No, like what is, like, I know R is correlation coefficient.
R squared is coefficient of determination. So 66% of the variation in travel time can be explained with an LSRL.
Came on the last problem.
What then?
I just want to.
always like that kind of sentence and then you just like replace
Yes.
your
Mad Libs.
yeah, okay. So you replace the travel time and the departure time with whatever your x and y variable are?
Mm-hmm. Last. Okay, which of the following which is minimized with an LSRL? So an LSRL minimizes the square of the difference between actual travel time and predicted travel time. You're right, it's the sum of the squares. Yeah.
Can something be minimized if it's not resistant? I mean, if it is resistant?
No, it still would be minimized. Okay.
What does that mean?
Okay. So what you know what it's going to minimize? It's going to minimize sigma y hat
Yeah.
minus y squared.
Yeah, we should start making it white house like this.
If only we had a Reddit for math doodles, you would totally win.
You could probably invent one.
I'm pretty sure that was one. I could probably
Math doodles.
Yes.
And I would have to counter that one with the conical Asian hat.
Did you want to buy one?
I want to buy one. Huh? I told you.
You have one for Halloween.
I'll be rated for Halloween.
Yeah, you need to get one so you can wear Halloween. So yeah, what's the latest you have?
Bye bye.